Hello everyone, I'm Shouliang from Shanghai JiaoTong University. I'm very happy to present our paper Locating Faulty Methods with a Mixed RNN and Attention Model here. So let's look at what is fault localization first. Given a bug report, the task of locating faults in software project is called fault localization. Why do we need fault localization? There are two main reasons. First, it helps to save time of programmers in the manual debugging process. Second, it is necessary for most automated program repair techniques. In prior researches, we could classify fault localization techniques into two mainstream value input. The first line is spectrum-based fault localization. It analyzes program execution information of test cases. However, test cases are usually not available when bug reports created. Therefore, error-based approaches have been widely investigated. It considers fault localization as a search problem. Bug reports are queries, and code snippets are answers. According to a survey, most programmers prefer to locate faulty methods. Therefore, recent approaches start to explore locating faulty methods, but their effectiveness is less impressive. In this paper, we focus on error-based approaches. As the number of methods is much higher than the number of source files, locating faulty methods is much more difficult. Besides this issue, we conduct a preliminary study to analyze three problems of locating faulty methods. The first problem is the single revision problem. A source method in a software repository often has a long revision history, but the prior works analyze only the latest code revision. This problem results in lacking of sufficient historical data to train a model. The second problem is the semantic gap between bug reports and source code. As bug reports are manually in natural language form, it is difficult to match them with source methods. The third problem is that lots of methods are too short to contain enough information to be localized. For the single revision problem, our solution is to construct code revision graphs. For the semantic gap problem and the representation sparse problem, we build a semantic matching network and short method expansion network respectively in our proposed MRAM. This figure shows the schema of code revision graphs. The code revision graphs offer the following benefits. It provides all revisions of code, bug reports, and commits to train the model. It provides related methods to expand short methods. It calculates multi-revision bug fixing features to improve the performance of fault localization. This figure shows the detailed architecture of MRAM. It consists of three main components: the semantic matching network in blue, the method expansion network in yellow, and the fault localization network in green. We first represent the source method by its three method struct features: the token sequence, the API invocation sequence, and the method command. To bridge the gap between natural language and the programming language, semantic matching network captures both semantic and structural feature information of a source method with bidirectional RNN and soft attention model. In this way, the source method can be matched with the bug reports in a unified vector space. For a method with a short length, method expansion network enriches the representation of it by retrieving the information from its relevant methods. Finally, fault localization network predicts the fault probability of a method by combining the implicit and explicit reference to the bug report. We conduct a series of experiments to answer the following questions. How effective is MRA in fault localization task. How do different components contribute to MRAM, and how does MRAM perform in cross-project fault localization? For research question 1, we compared our MRAM with baselines on 5 open source projects. As the table shows, MRAM improves top K, MAP, MRR under the setting with and without localized bug reports. One reason is that MRAM considers both the implicit and the explicit information. It provides more effective fault diagnosis information. To answer research question 1, we conduct an in-depth ablation study on SWT project. It helps to get a better insight in our proposed MRAM. The result is shown in this table. From the table, we can find out that code revision graphs are useful to resolve the single revision problem. Revised cooperative filtering score and method expansion network are useful to handle the representation sparseness problem. The fault localization in previous research questions is within project. Therefore, in research question 3, we extend the fault localization to cross-project setting to further investigate the effectiveness of MRAM. The result is shown in the table. From the table, we can find out that in the cross-project setting, the effectiveness of MRAM is only slightly worse than that of the within project setting. This indicates that MRAM can effectively transferred to a project with insufficient labeled bug reports. That's all.
Hello everyone, I'm Dario Dinucci. I'm your session chair for this session about impact on code. So I guess you have some questions, and in case you can put it in the chat. I just remember you that we have only 2 minutes. In the meanwhile, I have a question for Shouliang. So in your paper, you mentioned several features, so you really rely on different features, and I wonder which one is the most important. Which one do you think that is essential to mine?
In so many features, you mean which is the most most influenced feature?
Yeah, I mean you have a method tokens, API sequences, and the method.
In our experiments, we think the RCFS are the most influenced features because it records it shows the long history of a method in a software repository, and it reflects that if a method is a buggy method, then the method may change or may modify in recent time, and that it holds a great threat to be a buggy method.
Another quick question, because I don't see any question from the chat. Which step is the most computationally intensive? I mean, you have several steps. Which one do you think that it takes much more time? Oh, I don't see Shouliang anymore. I have no time to answer the other questions. In the meanwhile, I remind you that you can always use the discussion rooms. You can also use the chat. Also, please consider that at the end of this session, we have a social an event in the social room. So you need to switch the room from the ICPC main room to the ICPC social room. And yeah, see you soon.